Okay, everyone, welcome back. Today we're going to be looking at the blockchain project that I just created. So when you go to the page, you're going to see this. The whole idea of blockchain is that it is the underlying technology for cryptocurrencies, and then it is also edging its way into some other industries which happen to be really interesting. Some have been some contracts in certain industries, and there's a few other places where it is working its way. So the underlying blockchain technology is really cool and has really sparked interest in me. I actually had done a project in my senior year of college for one of my security classes about blockchain, and unfortunately I did not find the project that is listed here while I was doing the research for my senior project. I really wish I had. The guy Anders Brownworth has done an excellent job explaining, probably much better than I will be explaining, what blockchain is on his channel and on the videos that I've linked in there and the code that he provided, that I just wanted to get in there and make the demo page myself. He did this, and I'm going to say honestly his is much better, but I wanted to do it, and then I really wanted to walk through the actual code that I did. This is not to be a replacement of any kind of website security that anyone should be implementing themselves. If you want to get into that, please take some cryptography classes and really go down the path and learn all of what it takes to really do cryptography the correct way. I do also use the SHA-256 algorithm from this website. However, I am not endorsing it to be used as anything other than learning about hashing functions. So I did use that code. I did give credit in the JavaScript file, which I will talk about later. And again, I gave all the credit of the inspiration for this project right here. His website, his code, and both of his videos. Highly recommend going to them. Highly recommend that you really look through what he did. With all that said, the whole idea of blockchain is that you have these different blocks and they contain data. That data then gets hashed and gets added to the chain, the blockchain, and then becomes part of the data for that the hash number becomes part of the data for the next block in the chain. And that's how things get validated as they go. What I have done up here, this hash matching string, is going to be the first characters of this hash that it is going to be looking for. It's going to be mining for or searching for. So in this case, the first 4 characters have to be Fs, which this is hexadecimal, so it is the last number in hexadecimal. Then we go into our block. So this is going to be the first block in our blockchain. Therefore, its ID is going to be 0. I have already pre-calculated what the nonce is. There's going to be no data, so it's going to be an empty string. The previous hash is 0 because this is the first in our block. And so with all of this data getting hashed together, this is the hash that is calculated from that. If I am to change anything, then this becomes invalid because, again, this does not meet the requirement of having the first 4 Fs. So what this is going to do is it's going to look for the first nonce number. It's going to cycle through that is going to give it the first 4 characters F. So we're going to search for it, and this happens to be the first one that it found, and that is the new nonce for that. I can now add a block, and it's going to automatically give us the next ID. It's going to automatically give us a nonce of 0 just because we don't know what it's going to be. It looked for it already grabbed our previous hash, and again there's going to be 0 data. So we're going to leave that one blank for now, and we're going to search for that nonce. It'll input that for us and give us our new hash. And we can keep going forward. Now, one thing to note is if you have less restrictions here, so if you have only 1 F, it'll be really, really quick. The more you do, the longer it's going to take. And again, Andre Brownworth explains more into it's big O. It's talking about how long you can expect for that to take, and so you can play around with that information. I'm not going to go into much detail about that. Just know the more restrictions you put there, and they don't have to all be the same. It could be 1, 2, 3, 4 random numbers and letters up to F. But again, the more of them that you have, the more complex it's going to be, and so it's going to take longer to find a hash generally to do that. Now, the cool part is, and this is what makes it a blockchain secure, if I want to go and change this data, which could be like a cryptocurrency changing a transfer amount, or a contract changing a signature, or anything about that. If I change anything about that, everything else becomes invalidated. And the whole point is that it's a decentralized ledger, so everyone involved in the network has this copy of this ledger, and the mining portion of it, the calculation part of it, is checking all of those. And so if there is an issue, I do believe he uses a democratic way of determining which one's true. So if I think at least 51% of the network thinks it's one way and 49% thinks it's another, I think the 51% is what wins. So if you're able to hack into 51% of the network to get it to believe your new transaction, then that would work. I do believe. I'm not going to, don't quote me on that. So now I can go through and I can have it search again. And so now it has revalidated with that data. And it's put in the new hash, so it's revalidated, and it's going to revalidate. So again, this is just for demo purposes to show what that process looks like. And you can make as many of these blocks as you would like to, and they will all work that way. Sometimes it takes a little bit to get that back. As you can tell, that number's much bigger. We're in the 300,000s at that point. So all that has to do with is that, given the previous hash, all added together and hashed together, it just takes a lot to get there. And so that is the basics of blockchain technology, and I hope this will inspire you guys to take this, play with it, learn from it, and dig deeper, and maybe create something even more secure than the blockchain. Now, to start with the actual code, I'm going to start with HTML. Fairly simple. Title. We've got our 2 JavaScript files that we're bringing in, and then our style sheets. Again, our main one for blockchain itself. We have our header, our header for the specific page. This will be where our home button comes in. I preset our hash matching string. We have an input for that. Give it an onChange function, which we'll talk about in the JavaScript. Automatically give it the value of the 4 Fs. We give the first card, which is going to be that first block. This is the card wrapper. And inside there we give it the first card. You can give it 0. We have some class for the CSS, which we'll talk about that in a second. Give our block ID, our nonce, and our data. Again, I hard-coded this to start out with so that it would become green when the first block has been created. And that's, again, what this is. We have our search button, and we have our onClick function, again, and we pass in the block that it is. And so all of them are coded with the block ID of 0. So when we add another one, we will increase that. We then have our add button, our add block button, and then I just created a credit section to give credit to those who inspired it and the code that I looked at. Now I didn't really look at the code much. I did skim through it, but I did not start with that starter code. I closed that and went through it myself. But I just still did want to give credit to those who before me who created that. And then I did copy and paste for the SHA 256 algorithm. You can bring in libraries to do this. I decided that I wanted to make it even more. How would you do it if you didn't have access to the libraries? And so then you can also look at what that function is doing. So I copy and pasted it from here. Again, I'm not recommending using this for any actual real security. I did happen to test it, and it does seem like it is the accurate SHA 256 algorithm. But again, any code that you get off the internet, be highly cautious of. And I did want to give credit to where that came from. And then we have our footer. So to go to the blockchain.css file, we have our verified and our not verified. These are the background colors that I switched between for the blockchain blocks that will show if it's verified or not based on the hash string that's matching to. We have our previous hash input, some width styling. We have our card wrapper. I just want to do some width and margin. We have our search button. We have an add block button. We have add block button wrapper and our hash matching. So just some easy CSS there. Nothing too crazy. So as we step into our blockchain.js, we have the credits for the inspiration of the project. We have the hex string, which is going to be what it's matching to. So in our case, it's the 4Fs. So I just originally initialize it to. I grab the length of that and set that here as the most significant count. I now have an array of the blockchain. So it's actually a 2D array, an array of arrays. So in that we have our ID, we have our nonce, we have our data, our empty string, we have our previous hash, and we have the hash. Then we have our add block function. So we're going to have a new index. We want to keep that throughout here. The previous index is going to be the new index -1. We are going to push whatever the new index is. We're going to give it the nonce of 0 to start out with. We're going to give it the blank data to begin with. We're going to give it the previous hash. And then we're going to give it the current hash of null. So we have our total data. We're going to get the data JSON. We'll look at that function a little bit down below. And we're going to pass it in all of the information that we just added to the blockchain. And we'll save it into this variable. The blockchain for the new index, we will set the hash by calling the SHA-256 and handing it in all of this data that we just made into a JSON. And then we're going to reprint all of the blocks. So reprinting all of the blocks, we're just going to show, or we're going to print off each of the, or update the HTML for all of the data into the HTML. So we want to update all previous hashes, so make sure that they are all correct and that none of them have broken the rules. I will show you that here. So we're going to cycle through the blockchain for each of the blocks. If the block is greater than 0, then we're going to look at the third index. So that's 0, 1, 2, 3, looking at that previous hash. Making sure that it matches the previous hash that it's supposed to. So we're just going to realign all of those in case any of those got manually changed. And then we're going to make sure that the hash is of all of that data there. So this is what's going to help invalidate anything. We're going to make this is how we check that. And we do that before we reprint all of the blockchain cards. Then we clear out the card wrapper, and we start from the beginning, go cycle through all of the blockchain, so get every block, which is going to give us an index, and we get the block ID. We input that into the input, right? So we are making the ID. The reason the ID there, we're getting setting the value, so we know what so the input has a chance to be updated. Updating the onClick function, onChange function in this case. And we do that for each one of these. For the nonce, we're updating, again, the input ID, we're updating the onChange, and then the value. Same thing for data, the ID, the onChange, the value. The input ID, the value, because we're not letting them change the previous hash unless they go to the previous block and change that hash. We have our inputs, so I put all this in a separate variable. I add them together and put them inside of a div, and then create the hash and the button, and then I add all of that together here, so that we just cleared it out here. I go back into that inner HTML and I do a plus equals, so it keeps adding to, it appends to the inner HTML, and I add all of those together. We have one if statement here, and that's just looking at the substring of the first 4 characters. And this is why I needed that number of how many there are. If they equal, I give it the classes of card and verified. If not, it's card and not verified. We talked about the update all hash, update all previous hash, update hex string input. So these are just all of the input updates. So whenever they change, this goes through and it updates that information, and we'll reprint it. This is our search for nonce. So when we click search for nonce, this is what's happening. We're going to pass in the blockchain index, which got updated. Let me reprint those cards. And I go through and grab that individual information. I give it a start nonce of 0. And then we look at verification. So verify current input. So we're going to pass in the blockchain index as well. We are going to get the temporary hash from that based on all of its data. If the temp hash substring, again, we're going to double check while this is occurring if the significant numbers, the far left numbers, match. And then we will update that with the temp hash. And we will say it's verified or not verified. And we're going to return true with the temp hash or false with a null. So that's going to verify for us if it's verified or not. If it comes back true, then we will not have to run the. Basically, if we're running this on something that's already been verified, then we just do a quick check to make sure that all the data that's there works, and we return. If not, then this is where, and so let me back up. This is where we're removing the not verified and making sure we add verified. Otherwise, if it's not matching, then this is where we are going to have a hash equal null. While hash does equal null, and the start nonce is less than 5 million, then hash is going to equal cycle to get hash. And so we're going to pass in all of this information to this function, which was down here. And so if it returns, then we're going to keep going until it is obviously more than 5 million, and we're going to add 1 million every time. So we're only doing a million chunks to begin with. So you can always increase this, but then it's just going to be longer that it's going to go and search for it. Once that comes back, then we are going to update the blockchain array. We're going to update the nonce input and the output inner HTML. We will update the card, remove the not verified, add the verified, and reprint the blocks. Now let's talk about what the cycle to get hash is. We already talked about verify current input. So cycle to get hash. So cycle to get hash has our start nonce or non-start, nonce end, block ID, data, and previous hash. So we'll start with whatever nonce start we have, and we'll cycle through. And that'll be our I that we pass in to our hashing function. If those first significant numbers match, then we return. If not, we just keep going. If we go all the way to the end, then we just return null, and then that's where this will get called again with this while loop. If input is changed, then that is where we will get the JSON. We will update the hash. We will update the inner HTML with that hash. Check to see if it matches. If it does, we remove not verified, add verified. If it doesn't, then we remove verified and add not verified. And then we reprint the blocks. Getting the data JSON, we pass it on the data, and we just simply add it to this string, and we use JSON.stringify, so we make that string a JSON. I take that back. We take this as JSON, and we turn it into a string. This is actually our JSON right there, and we turn it into a string that we then hash. Now all of this is the code that I had copy and pasted from this website. And so I'm just passing in the string. So you can walk through. I'm not going to walk through this code here. Feel free to walk through it yourself. This is basically this is the SHA 256 algorithm. Hope you guys found that interesting, and I hope you guys take it further than I did and learn more about it.